Welcome to another video by Adeptis Academy. At its core, an algorithm is simply a set of instructions, a recipe for solving a problem or completing a task, no matter how big or small. It's a way to break down something complex into a series of manageable, logical steps that anyone can follow. Think of it as a logical plan, not some mysterious code reserved for computer scientists. Algorithms are everywhere, woven into the fabric of our daily routines, whether we notice them or not. These instructions must be clear, precise, and have a definite start and end. If the steps are vague or incomplete, the outcome can be unpredictable or even fail entirely. You use algorithms every day, often without realizing it. From the moment you wake up and follow your morning routine, to the way you decide what to eat for lunch, you're following step-by-step processes, algorithms in action. Imagine assembling flat-pack furniture. The manual is an algorithm, guiding you step by step through the process. Each instruction builds on the last, leading you toward a finished product. If you follow the steps, you get a sturdy bookcase. Skip one, and you risk a wobbly mess. The importance of order and clarity in instructions becomes obvious. This is the power of algorithms, breaking down chaos into manageable steps for predictable results. They help us organize, prioritize, and achieve goals efficiently, whether we're working alone or as a team. Algorithms aren't new. They've been around since ancient times, used by mathematicians in Babylon and Egypt to solve problems, keep records, and even predict the movement of the stars. The word algorithm comes from the Persian mathematician al-Khwarizmi, whose groundbreaking work laid the foundation for algebra and influenced generations of thinkers. Today, algorithms are supercharged by computers, but the principle remains the same: clear instructions to achieve a goal. Computers just allow us to run these instructions at incredible speed and scale. What's changed is the scale. Algorithms now guide self-driving cars through busy streets, recommend movies tailored to your taste, and help doctors diagnose diseases with greater accuracy than ever before. They're the building blocks of our digital world, shaping everything from how we communicate to how we learn, work, and play. Algorithms are quietly transforming our future in profound and sometimes unexpected ways. So next time you hear the word algorithm, remember, it's just a smart, step-by-step plan designed to make life simpler, more organized, and a little more predictable. Let's bring algorithms into the kitchen, where step-by-step thinking is as essential as the ingredients themselves. Making a peanut butter and jelly sandwich? Believe it or not, that's an algorithm in action. Just like a computer program, but tastier. Imagine you had to write instructions for someone who's never seen a sandwich before. You'd need to be incredibly specific, breaking down each action into clear sequential steps so nothing gets missed or misunderstood. Step 1. Gather your materials: 2 slices of bread, peanut butter, jelly, and a knife. Each item is essential, just like variables in a program. Step 2. Place the bread on a plate, setting the stage for what comes next. Step 3. Open the peanut butter, scoop some out, and spread it evenly on one slice. Precision matters, just like in code. Step 4. Clean the knife to avoid mixing flavors, then open the jelly and spread it on the other slice. Each action builds on the last. Step 5. Put the slices together, spreads facing each other, and press gently. The process is complete. Done. You've just followed a finite, unambiguous set of steps to reach your goal, a delicious sandwich. The order of steps matters. Try spreading before opening the jar, and you'll quickly see why algorithms need to be precise and logical. This simple process is a real-world algorithm, not just for computers, but for everyday life. Recipes, instructions, and even morning routines all follow algorithms. Algorithms help us organize tasks, avoid confusion, and get consistent results, whether we're cooking, planning a project, or learning something new. Whether you're in the kitchen or coding on a laptop, clear instructions are the secret ingredient to success. Both worlds rely on logic and order. Next time you make a sandwich, remember, you're thinking algorithmically, breaking down a problem and solving it step by step. Algorithms are everywhere, guiding us from start to finish, helping us turn ideas into reality, one step at a time. Now, let's see how algorithms power computers and shape the digital world around us. Algorithms are the step-by-step instructions that tell computers exactly what to do, transforming our ideas into reality. Computers excel at following instructions, but they have zero intuition. They don't make assumptions or fill in the blanks like humans do. Every step must be explicit, no guessing allowed. If a single instruction is missing or unclear, the computer simply stops or produces an error. A computer program is just a complex algorithm, or a set of them, written in code. These programs can be simple, like a calculator, or incredibly complex, like the software running a spaceship. You give input, the algorithm processes it, and you get output. This process happens billions of times every day, often without us even noticing. For example, a calculator, when you enter 2 plus 2, the algorithm adds the numbers and displays 4. It's a simple task, but it demonstrates the power of clear instructions. The computer doesn't know math, it just follows instructions perfectly, without understanding or creativity. Algorithms bridge human intention and machine action, turning our commands into real-world results. Programmers translate our plans into code, Python, Java, C++, so computers can execute them with precision, speed, and reliability. From sorting names in a spreadsheet to rendering stunning video games, algorithms guide every digital action, big or small. Their power lies in speed and scale. Computers can run millions of steps in seconds, handling tasks that would take humans years. Algorithms are the invisible engines behind every digital task, quietly shaping our modern lives and making the impossible possible. Search engines like Google rely on powerful algorithms. When you type a query, the algorithm sifts through trillions of web pages in seconds. It doesn't just match words, it tries to understand your intent and ranks results by relevance. The algorithm considers hundreds of factors: page content, links, freshness, speed, and even your location. It learns from billions of searches, constantly improving its accuracy. Without this ranking, you'd get a chaotic list of results. The goal: predict what's most helpful and put it at the top. Every search is a showcase of algorithmic power, turning a few words into useful answers. Search algorithms have revolutionized how we access information. They're the silent force making the world's knowledge accessible in an instant. On sites like Amazon, algorithms act as your personal shopper. Recommended for you isn't random. It's powered by collaborative filtering. The algorithm analyzes your behavior and millions of others to predict what you'll like. If you buy a gardening book, it suggests gloves or more books based on similar users' choices. Every click, view, and purchase is a data point, refining recommendations. This feedback loop makes suggestions more accurate over time. Algorithms help you discover new products, but can also keep you in a filter bubble. They shape our shopping habits, one recommendation at a time. Algorithms personalize the vast digital marketplace for each of us. GPS apps like Google Maps use navigation algorithms to guide you. The goal: get you from A to B as efficiently as possible. These algorithms analyze real-time data, traffic, accidents, road closures to find the best route. Dijkstra's algorithm, for example, finds the shortest or fastest path by weighing each road segment. The app constantly recalculates if conditions change, suggesting detours when needed. This dynamic problem-solving saves time and reduces frustration. Algorithms turn a complex, ever-changing road network into simple directions. They optimize routes for millions, managing city traffic in real time. Every turn-by-turn instruction is the result of relentless algorithmic calculation. Navigation algorithms quietly make our journeys smoother every day. Algorithmic thinking isn't just for computers. It's a life skill. It means breaking big problems into smaller, manageable steps. For example, cleaning a messy room, pick up clothes, sort them, put dirty ones in the laundry, fold the rest, and throw out trash. This step-by-step approach makes daunting tasks doable. You can apply it to planning a trip, studying for exams, or any challenge. Create a logical sequence. Define your goal, break it down, and tackle each part. Algorithmic thinking brings clarity and structure to problem solving. It helps you plan, make decisions, and work efficiently. Ask, what's the first step? What comes next? Are any steps dependent on others? Anyone can use algorithms to solve problems with confidence and logic. Algorithms are the invisible architects of our modern world. They guide us in the kitchen, power our searches, and direct our journeys. Every time you stream, shop, or get directions, an algorithm is at work. They filter information, personalize experiences, and automate tasks at massive scale. Understanding algorithms is now essential digital literacy. Thinking algorithmically helps us tackle challenges with clarity and confidence. The core principles, sequence, logic, precision, are tools for both machines and humans. Algorithms shape our reality, from finding the fastest route home to discovering new music. They're not magic, just smart instructions, supercharged by technology. In the age of algorithms, understanding their logic helps us navigate and thrive in a digital world.